Hello, I'm Amy Kaiser from MIT, welcoming everyone to the program. It's my pleasure to introduce Christiane Lum, moderating our next panel, Bias and Equity Within Data Science. Christiane is Assistant Research Professor in the Department of Computer and Information Science, School of Engineering and Applied Science at the University of Pennsylvania. She studies and develops statistical and machine learning models to tackle problems with social impact. And prior to her current position at UPenn, Christiane was lead statistician at the Human Rights Data Analysis Group. In her own words, she is often just as, if not more, interested in what is missing from a data set than what is in it. And with that, I turn over the spotlight to warmly welcome Christiane Lum. Welcome.
Thank you so much. And so I guess I'll take this opportunity, thank you for the nice welcome, to also welcome the panelists that we have here today. I'm really excited to have this discussion about bias and equity within data science. So to do that, today we have Hima Lakkaraju. Hima is an assistant professor at Harvard University with appointments in the business school and the Department of Computer Science. She works in the broad area of trustworthy machine learning. More specifically, her research spans explainable, fair, and robust ML. She leads the AI for Life research group at Harvard and recently co-founded the Trustworthy ML Initiative, TrustML, to help lower entry barriers into the field of trustworthy ML and bring together researchers and practitioners working in the field. Our second panelist is Ahi Nosocare. Ahi is a senior data scientist manager at Microsoft. She leads a team that designs, develops, and implements ML solutions in application projects across Microsoft's products and services. At Microsoft, she has worked on responsible AI projects, including Interpret Text, an open source interpretability toolkit for NLP. She holds a PhD in electrical engineering and computer science from MIT, where she worked on interpretable machine learning algorithms for mental health and well-being. And our third panelist is Lauren Klein. Lauren Klein is an associate professor in the Department of English and Quantitative Theory and Methods at Emory University, where she also directs the Digital Humanities Lab. She works at the intersection of digital humanities, data science, and American culture, with a particular emphasis on issues of gender and race. She is the co-author with Catherine D'Ignazio of Data Feminism, which offers a new way of thinking about data and data science that is informed by the past several decades of feminist activism and critical thought. All right, so those are some really great bios. I'm sure we're all enthusiastic to hear what these people have to say about the questions we have today. So what I'm hoping, I don't have a whole lot of questions. I'm hoping we can have somewhat of a conversation among the panelists. And so I think maybe the best way to do that, since I gave the introduction that was sort of all of your titles and sort of the general idea of what you work on, I was hoping we could get a little bit more into what you work on. So the topic of this panel is bias and equity within data science. And before we discuss bias and equity within the field of data science, I'm interested in learning more about how each of you use data science to address bias and inequity in the real world. Could you each spend a few minutes as sort of an extended introduction beyond the titles I just listed off, telling us about your work and uses of data science and or machine learning to address bias and equity in the real world? And let's start with Hima.
Thanks so much, Christian, and nice to see everyone here, and hi to all participants at WiDS Cambridge. Let me start by talking a little bit about what my research is, and then I can also discuss a little bit about how it connects to solving bias and equity problems, broadly in the society, right? So I focus on, developing models or, tools that can be understood by human decision makers, and that has been like one of my primary research areas, which is broadly again referred to as explainable AI or explainable ML. And the idea or one of the goals of doing so or being interested in this topic is to basically expose how machine learning models are functioning to humans so that humans can potentially intervene and detect any harmful biases or undesirable biases in the models, right? This could be a racial bias, this could be a gender bias or any other form of like demographic bias, or it could just be in the form of using, the model itself using features or aspects of the data that are irrelevant to the prediction, right? So just to give a simple example, where can explainability help? One of the reasons or one of the pieces is, let's say if you were just classifying or constructing a classifier that just like determines if an image is a cat or a dog, and if a model is actually using the background color of the images to make predictions, of course it's using a pretty spurious feature, and we would not know unless we sort of probe more into the model or understand how the model is behaving, right? So this is also an undesirable bias that the model has, but of course is not related to like a racial or gender bias. And in other situations, the models could just be biased on certain races. They could actually be using a race variable when making predictions or a gender variable when making predictions. This information also we will know when we probe the models or try to understand what's going on, right? So this is how explainable ML or understanding model behavior can contribute to potentially promoting equity or like removing biases through human intervention in machine learning models. So that's where majority of my time is spent on. Apart from this, of course, I work specifically on developing models that are robust to adversarial examples, and models that are explicitly encoded to satisfy certain fairness criteria. So this is pretty much like a high level summary of my work, and how all this relates to making things more equitable in the society is, as we all know, machine learning models are becoming more ubiquitous. They are being employed in several settings like healthcare or, like making decisions in finance and so on. So in all these things, equity is important. So the work that I do is about building models that respect fairness and equity and try to remove as many undesirable biases as possible within the models. Thereby, we hope that the decisions that are being made through these models and which affect individuals in the society are also fair, and there is some notion of equity maintained in those decisions.
Thanks, Hema. I often find it easier to understand these ideas when it's sort of fixed with a specific example. Could you give a specific example of a project that you've worked on where you have, designed a model that respects certain notions of fairness, and, in some specific contextual environment?
Yeah, no, that's a great point. So yeah, I think one of the things that let me talk a little bit more about my work with some collaborators, which has been like deployed or is being considered for deployment in real world settings. So one work that we were doing recently is by collaborating with certain hospitals in the Boston area, as well as also working with some NGOs in India to develop models that are going to allocate resources like ventilators, or even like which doctors should be assigned, and like how much the treatment should be priority for patients, right? So allocating resources in a fair manner by basically respecting again, fairness constraints. And in that regard, basically what we were doing is building fair classifiers and fair resource allocation algorithms, which ensure that people from different socioeconomic backgrounds, people from different races and genders, are all being given these resources in an equitable fashion. For example, if someone needs a bed because they are recovering for COVID and they have to be hospitalized, allocating these resources in a fair manner so that there's no discrimination happening between different genders, right? So similarly, if someone needs a ventilator, again, as they're recovering from COVID or as they're being treated, how to allocate these kinds of resources, and ensuring that there are no, racial or any other kind of demographic discrimination that is happening, is one of the recent problems that we have been working on in partnership with like several hospitals and other places also. So yeah, both in US and in India.
All right, great. Thank you. How about Ahi?
Yeah, so I have a very similar background to Hima in that I also work in interpretable ML or explainable ML. And what I do is we try to develop tools that would make it easier for industry practitioners or developers to integrate interpretability in their work streams. Because some of the things that we see in industry, especially for responsible AI, there's a lot of advancement on the research side of things. there are tons of cool explainable techniques that do come out from research institutions, but it becomes harder for those developers to apply those things directly when they're developing products. Part of it could just be things that come out of research maybe is not as robust code-wise, or just the knowledge gap between what's been developed as state of the art and what needs to be applied in the industry. And so part of the work that we do in my group is like, how do we build sort of like stand in the gap, translate research into products that would now enable developers to be able to use these technologies in their day-to-day work. An example of this is the open source Interpret ML that we developed, and that was how do you bring interpretability to NLP models. And part of it was we had different types of explainability techniques that were gotten from MSR Asia, from MIT CSAIL, as well as just a classical glass box model. And so you have the entire range of, or at least the range from classical ML techniques all the way to how do you look into deep learning models. And so developers have access to these tools, and it's a lot easier for them to use. That's one aspect of the work. I think another aspect in terms of looking at bias is just looking at the data set that you have, right? Like what exactly is going into these models? How representative is your data sets? Checking your assumptions. What are some of the assumptions that you're making as a data scientist when you're developing these models? Because all these things do end up leading to bias. And so something that we end up doing in my group is we call like this Responsibly AI Checklist. So where we're constantly checking our assumptions, the data set, what is the makeup of it? Is it representative? We're trying to develop this model. What does it look like? What does it mean? What features are we choosing and why? What are we letting go of? And how is that? So sort of bringing that into our consciousness as we develop, and so that the entire cycle, right, from when you pick up your data to when you build your model, and when you're trying to understand your model, you are checking out for biases.
Great. Thank you, Ahi. How about Lauren next?
Hi, everyone. I'm so glad to join this panel already. It's so exciting to learn about everyone else's work. So I come to this from a actually a very different perspective. I work in the field of digital humanities, which involves sort of two parallel approaches. One is taking humanistic theories and methods and applying them to technical and computational objects. And then the other is sort of the inverse of that. So using computational methods and applying them to pursue humanistic research questions. And my own work actually does inhabit both of these areas. So I think that the reason why I'm on the panel is because I recently co-authored a book with Catherine D'Ignazio over at MIT called Data Feminism, which tries to do pretty much exactly this. Think about how the long history of intersectional feminist theory and activism can let us do better data science. So this application of humanistic ways of thinking to how we practice data science in the world. In my own research, though, I actually use a lot of NLP and related machine learning techniques to tell stories about historical social movements. To give a specific example, I'm involved in a long-term project that is looking at the discourse surrounding the abolitionist movement of the 19th century United States. And one of my primary interests is sort of how we retell the story in a way that gives more visibility to the actual people who were working on the ground to make this change. And these people tended not to be the white male abolitionists who get credit in the sort of historical narratives we tell about how the end of slavery took place in the United States. And instead, it happens to be mostly Black people and Black women in particular who were in the room, who were organizing, who were out doing outreach all of this time. But because they did not have access to the print record, to sort of these other social networks that allowed the leading abolitionists to be credited for their action, we sort of tell the story differently than how it actually happened. And so I am involved in a series of projects that try to look at the sort of the big data sets of the 19th century, sets of newspapers, meeting minutes, things like this, and trying to look for signals in language change and signals and changes in social networks in order to try to identify some of these actors and some of these ideas that were really leading the charge at the time, but have not sort of been part of the story that we tell in the present about how that change took place. And then maybe I have some contemporary applications, but maybe I'll stop right there for now.
That's fantastic. So I think one of the things you touched on a little bit was using data science to expose different perspectives, perhaps perspectives that have been underappreciated in the past. And this sort of different perspectives, I think, pervades a lot of the discussion of biased algorithms. So I have a question for Hema, but I think if anyone else wants to weigh in afterwards, that would be fantastic. Like I said, I think this would be great if it could be a discussion. So to Hema, the question I have is that the term biased algorithm seems to have become kind of a catch-all term for models behaving in undesirable ways, especially with regard to racial, ethnic, or gender disparities. How do you grapple with the many different perspectives on what bias might mean in your work?
Right. That's a great question. Thanks, Christian. So I think I just want to start answering this question by saying something that happened in a recent conversation. So basically, when some of the students in my group were talking about bias with another statistician, he was a little surprised that they were using the word bias almost never to mean the traditional bias that is considered in machine learning and statistics, right? Like the bias and variance trade-offs that we have heard of traditionally before. I think people started using this term more and more to refer to undesirable biases. So he was almost like kind of surprised by how it has like almost synonymously become like equivalent to bias means undesirable biases, mostly racial biases, mostly gender biases, and so on. But yeah, I think my when people use the word bias, or when we use the word bias in our work, there are three different kinds of biases. One is a very traditional bias, model bias, in the sense of like traditional ML and statistics definitions, which is basically a model is making some assumptions about how the data is or what it is trying to model, right? So like for example, just to give a sense of like what would that mean, simpler models like logistic regression might have higher biases. So basically they're making more assumptions about how they're modeling the data or what the data would look like, whereas more complex models would have lower biases because they are going to learn whatever is in the data more without any specific representational assumptions about what a model should look like, right? So that's a very traditional notion of bias, and that also occurs in some of our works. Now coming to the bias in the form that is being used, of course, in the context of this panel, as well as like more broadly these days, is bias is referring to these undesirable bias. And even in that broad notion of bias, I would consider two separate categories. One is, as I also talked a little bit in my initial answer, more of racial or gender or age based or any of these like demographic biases, right? So these are potentially, we also call this as like discrimination, because these are undesirable. We do not want our models, or pretty much any human also, to discriminate based on race or gender and these kinds of attributes. Then there is another kind of undesirable bias that I also started in my initial example with, where the model is using some information which is irrelevant or spurious to make decisions, right? So as I was giving this example of cat versus dog classification, ideally a model should look at features like the cat's eyes or nose or something like that and make predictions. But if it is looking at background color and making predictions, clearly it's using irrelevant information. So that could also be considered as an undesirable bias. But roughly these are the three notions of the word bias that come up in the work that I do.
Fantastic. And sort of how do you balance prioritizing, maybe adjusting for or addressing those different types of bias in your work?
Yeah, that's another very interesting question. So I think there are, again, different ways to approach this problem of how to detect and also how to root out biases, right? So these are, again, like these things are complex enough that we can think about them as two phases. Do we even know if the model is having some undesirable biases or capturing some undesirable biases? If so, how to detect it? And once we know that the model is in fact capturing some undesirable biases, then how to root them out? So these are like you could think of them as a single shot problem, but given their complexity, people have often been thinking about them as like, two separate phases, right? And me and Ahi have also actually been talking about explainable ML. So that is one of the ways in which we could potentially detect biases, right? So an explainable algorithm or a tool can help us understand how the model is behaving, what features is it relying on, and so on. And that could potentially help us detect, oh, is this model likely to have any undesirable biases, right? So that's one
I'm
way.
actually going to stop you there then, because I was going to ask Ahi a question about almost
Okay.
exactly on that. And so thank you. That's a great segue into the question I had for Ahi. I might not even have to say it out loud. It's essentially on that, but I'll say it anyway. So some of the most prominent examples of bias in AI have come from NLP. So in particular, I'm talking about that 2017 Science article by Kaliskin et al. That shows that NLP models pick up on some undesirable biases, the same undesirable biases as humans. And I'm wondering how your work on explainable NLP speaks to those issues, and if that's one potential path forward in mitigating those problems.
Yeah, very great question. I think part of, following up by continuing what Hima was talking about in terms of explainable AI, that is one approach. Definitely not the only approach that should be taken. But even before getting to figuring out how to even mitigate, I think it's very important to understand what kind of bias are you even mitigating for. Like what you just said, it's a very loosely defined term. So some of the ways we tend to think about it is not just bias, but also what sort of harms are we trying to mitigate for. And so once you can understand those kind of harms, like are you looking at harms as a result of societal biases, algorithmic biases, or representational harms, then you have a better sense of how you can mitigate for that. And one way explainable AI can help is really understanding the models that you're using. NLP has moved so quickly in the past couple of years, and the more accurate the results have gotten, it's usually as a result of all these black box models, right? They're usually deep neural networks. And so there isn't so much of an understanding as to how these models are working on the inside to surface the results that they're surfacing. So one way to do this is in understanding or trying to explain how these models are working. And you can do it in different ways. You can use, well, in the simplest of terms, if you use like very simple black box models where maybe like a logistic regression, you understand, like, what the coefficients mean, you can interpret that fairly quickly. And there's a lot of, there's a lot of work in that space, even in industry, right? There are very simple models that people still use. But on the more complicated model side, you can have models where it's this kind of like after the fact approach, ad hoc. So now you've already built this black box model. Then you now take that model that has been trained on a particular data set, and then you apply some additional explainable model on it. And then it helps to interpret what this model has just either predicted or classified or generated. And so in understanding, what tokens are being used for this classification tasks, or what word is important to which layer, you're better able to see, where some of those biases are coming from, or at least trace back, where, or at least help mitigate that. There are some other models that are plug-in models where you include them in the training process. And so it's not so much like an after the fact thing. It's like, it's like a symbiotic training. As you're training your model in your data set, you're also training this interpretable model alongside with it. So at the end of it, you have not just your task, which may be prediction or classification or regression, but also some level of explanation with it. So explainable AI is one way. I think that really helps to do that. Another way, which I think that I alluded to earlier, is also looking at the data sets that we're using. I think especially with NLP, it's become the norm that you just scrape all of the internet, you train your models, and you get some sort of output. The internet is not the best place to get models that would be unbiased, right? Just because of all the things that we see on the internet on a day-to-day basis. So I think thinking a little bit more carefully about the data sets that we curate. So having more human-centered design as we collect data, and making sure that we have very clear objectives, right? Like, this is what we want to generate this. This is the data set that we're using, as opposed to just let's just use all of the internet and we would get like better results. So yeah, so my work has focused specifically on building explainable models, but I haven't really had I've not had time to go more into data sets, curating data sets aspect of it, but I do think that's also a very important way of making sure that we are building models that are not biased.
Great, thank you. Lauren, it looks like you're back. You dropped off for a second. So I'll get to you quickly here just in case we have any more issues. So Lauren, I have a question for you about feminism. So I think for many people, it's not obvious how feminism can inform data science practice beyond issues of gender inequality. And so I'm curious, how do you use feminist theory, if you do, to guide your work in data science? And how specifically do you use these ideas to tackle issues of racial equity?
Sure, thank you. And apologies, everyone. The power went off at my house, and now I'm back here on my laptop. Excuse me. So one of the things that Catherine and I discuss in the book is that feminism is sort of a shorthand term for an incredibly rich and long and capacious body of work that thinks about questions of inequality very, very broadly. So, over the past 40 years, scholars, for the most part, began by thinking about questions of inequality with respect to gender. But as they began to probe these questions of inequality, they realized that you couldn't just explain inequality only sort of along only one dimension of difference. And more specifically, scholars of intersectional feminism, so who really try to theorize the way in which multiple dimensions of difference intersect and produce differential effects on different kinds of people, as a result of the sort of range of identities that they inhabit in the world. These scholars have helped us to show how this framework, the sort of feminist framework of thinking about inequality, actually can be applied as an analytic to understand many, many different types of inequality that we encounter in the world. And so, another way of putting this is to say, feminism, we might think it has to do only with women. That's not really true. We might think it has to do only with questions of gender. That's also, not really true. What feminism is really after, it's about questions of power and how power and these imbalances of power that exist in the world, and this actually has to do with the previous conversation about how biases creep into our models, right? These larger imbalances of power that essentially overdetermine every single thing that we do, these are what need to be understood so that we can pursue a more equitable future for people of all genders, and for people, just for people, period, and sentence there. And so just to give an example of, an issue that you might not think has to do directly with feminism, but that I actually do take up in my own sort of data-driven work, has to do with questions of labor. And, this is another situation where we see inequities with respect to labor. So you can just say, okay, a feminist lens alerts you to ways in which power is not distributed equally in the world. And so there's a whole tradition of feminist labor studies scholarship, which looks at the differences in the way people are paid for the work that they do, the way people are compensated for the work that they do. Why is it? And I think the pandemic has, made this very clear to everyone. It does seem to be that there are certain forms of labor that are valued and compensated and enabled in the world, namely, business and the jobs that we do outside of the home. And yet the work that we do inside the home, this is what feminist labor studies scholars call invisible labor, because it is hidden from the public eye, because it is invisible to the market, right? We're not paid for this kind of work. And yet it is necessary, right? And in some ways, it's been called reproductive labor because it's the kind of labor that sort of enables the productive labor of the marketplace in order to take place. So to sort of bring this back down to earth, sort of like, away from theory land. So it's really sort of feminist thinking that has allowed us to atomize the ways in which sort of work is structured and valued and compensated along these sort of differential lines, right? And so once you have this understanding of how work happens, you can actually use this to direct research questions. And so one of the projects that I have relating to that project that I was talking about a little bit earlier has to do with some of this invisible labor undertaken by different groups in the 19th century and asking questions about how, if it is possible, because essentially what these large scale analyses allow us to do is abstract, to sort of zoom up a level and see large patterns. Is there a way that we can somehow sort of make the work that is taking place more tractable by abstracting, by aggregating, by doing all the things that we know how to do with data analytical tools. And so, for example, I have a paper that looks at the work of newspaper editors, right? And so these are not people writing the articles, with their names, attributed in the byline. It's not the people publishing the newspapers giving their money so that their name could appear on the masthead. It's the people sort of doing the assembling of the words on the page, doing the editing, deciding like, yes, I want to include this article. No, I don't want to include that other article. And so what I do is I topic model this large corpus of newspaper, and I use some techniques from information retrieval, and you're able to sort of get a sense of this invisible labor that these editors were doing. And sure enough, you find that some women editors who were less acknowledged by name or in the sort of standard narrative of the sort of publishing barons of the 19th century were actually innovating more. We're pushing the bounds of what qualified as content. We're bringing new issues and earlier into the public conversation. You also get documentation of other types of labor, the real physical costs, especially of Black women newspaper editors, who not only had to contend with resistance that they faced as a result of their gender, but also as a result of their race. And so I could go on, but anyway, so this is sort of one example, but once you begin to see how feminism really does give you this lens for thinking through inequality and sort of gives you a conceptual model for understanding how it works, you can start to operationalize that model in your data and look for patterns that either represent it or that help understand it, or ultimately, ideally, sort of help push back against it and rebalance some of these sort of unequal power relations that we're trying to address.
All right, so let me try to bring you back even more to earth, maybe down to like sub-earth or something. So Ahi talked a little bit about the need for more careful attention to the curation of data that goes into the models that, NLP models, any sort of machine learning models that are being developed. What specifically do you think this sort of feminist lens can tell us about how that process should go?
I'm so sorry. Can you just repeat the question? You cut out at that minute.
Oh, did I? I'm sorry. So Ahi was talking about the need for care in the curation process for the data that goes into the development of machine learning models. And I'm wondering how the feminist lens you described could inform that kind of process.
Sure. I mean, I think the first thing to recognize is that this part of the process matters so deeply, and in a way, and actually it's pretty connected to what I was just talking about, it is not valued as much as it should be in the data processing and data analysis pipeline, right? We tend to give a lot of credit to people who develop models, to people who publish papers, and it is rarely those individuals who are creating the data set or cleaning the data set or preparing it so that it can be analyzed. And yet we know is that those choices matter so much in terms of what the models tell us, right? And so a feminist approach would say, number one, you should recognize that. Number two, you should respect and value that, and you should think harder about that. But I would say more than that, a feminist approach sort of teaches us to look more broadly sort of at what it is that we're doing when we're modeling anything. And look at the process that sort of takes place before you even begin to collect data on whatever particular phenomenon you're looking at, to ask yourself, why is this a phenomenon in the first place? Is it possible to capture this in the data? And given that we do need to, in some ways, reduce what are always more complex phenomena than what we can actually study, what elements of this issue are we actually learning about? When we create our data sets, when we model something, when we propose, whatever it is, whatever results we get, like what are we able to say and what is the scope of the results? And so thinking back, the beginning of the process, and then afterwards, one of the most powerful feminist interventions that I've heard recently actually isn't coming from someone who I would think anchors her own work in feminist theory, although I do think this is an influence, is Wendy Chun's group at Simon Fraser. She works on the Digital Democracy Group. And she has a book coming out soon called Discriminating Data. And she says, look, if what we see as the output of these models, if the especially predictive models, if what's coming out is biased, we should say, okay, yes, they are biased, and it's not our job to debias the algorithm or fix the data or whatever it is. Let's use this as an example of what not to do and sort of imagine otherwise. Say, okay, well, this is what would happen if we accelerate our already existing biased choices. Let's imagine otherwise. Let's imagine another possible future. And that's another thing that feminism teaches us to and encourages us to do, is to sort of not stick to the previously trodden path and look to other people who were not previously part of the process for inspiration and ideas about how to go in the future, where to go in the future.
Great. Thank you so much. All right. So far, I think I've actually kind of skirted the intention of this panel, which again is bias and equity within data science. I think I've sort of spurred some questions that are, bias and equity more generally or more broadly. And so I want to actually finally address what I think the intention of this panel was meant to be, which is bias and equity within data science. So we have discussed how using data science to look outward and better understand issues of bias and promote equity in general. How can we use our own tools to look inwards and address bias and inequity in the field itself? Or alternatively, what non-data science tools or approaches are most effective to this end? And how could we merge traditional data science techniques with other tactics to make the field more equitable? Maybe I'll change up the order a little bit this time. How about Ahi? Do you want to go first this time?
Yeah, sure, absolutely. I think for me, mine is a non-data science technique and is representation. I feel really strongly about it. Just because when you have a diverse group of people working on an issue, everyone comes to the table with their unique perspectives. And if certain groups are marginalized, sidelined, we will never benefit from their opinions or their own ways of approaching problems, right? There are multiple ways that we can approach problems. And if we're not, trying to tackle it from multiple different angles, I sort of feel like we're not doing that good of a job. So for me, I think it's representation, and that is across the entire pipeline, right? The graduate students who are working on these issues, the faculty members, the people in the industry, who is getting funded for research, right? Especially people who are not in R1 institutions, they sometimes tend to tackle some of the toughest issues that relate to bias and inequity, but they don't get recognized, they don't get funded, their research doesn't really get promoted. So I think for me, my non-technology solution would be representation across the board. Yeah, I'll stop there.
Okay. You can go on if you have more to say, but if you'd like to pass the mic, that's fine too.
Yeah, no, I'll pass the mic for now.
Okay, great. How about Hema?
Yeah, no, I think I actually agree with. I come from the school that I think we should attack any given problem from multiple angles. It can't just be one or the other. So I agree with Ahi's points that I think representation is one of the most important piece in the puzzle. And since Ahi has also so elegantly touched upon that, I'm going to probably touch upon a few other aspects, which probably already came up in some of the earlier discussion. But I think emphasis on or recognizing the work involved in building the pipelines, right? So people often have a tendency to brush this process of data collection, or even, the time spent on pre-processing the data, or all of these aspects as it's an engineering task, right? But I think the more effort and, diligence we can apply to that part of the pipeline, the better position we are in terms of increasing our chances of having lesser biases in the model. Of course, that will not eliminate everything. There are still going to be the model training process, which could induce its own biases and so on. But, I think we should also give enough credit for people and, the effort that is being spent on collecting good data sets, representative data sets, and the time spent in pre-processing those data, all of these parts of the pipeline, which is not done enough. It's often, again, as I said, brushed as something mechanical or part of the engineering piece. And of course, beyond that, I think just the process of being vigilant in when developing models, and just kind of keeping an eye out for, now that we know that models could be susceptible to these things, let's make sure that we check any model that we build to make sure that it passes all these minimum checks in terms of difference fairness metrics, in terms of if it's robustness, in terms of even like just probing through some explainability tools. I think every time a model is developed, ideally, I think we are getting to that point. I think there is now enough critical mass in terms of literature in each of these fields that we could potentially develop like some kinds of checklists again to say that here is all the things that your model should pass. These are like the bare minimum, not that that's the most exhaustive thing, but at least these checks need to be passed before you even try and think about like putting it in any real world situation.
All right, thank you. So I'm going to try to turn the question back a little bit. I think maybe I didn't express it well before I go to Lauren. So my question is less about how to develop the models and more about sort of the atmosphere within the field itself. So is it possible to use our own tools to sort of bring about more equity within data science or less bias? And, I think a valid answer to this is that you don't think there is a problem with bias and inequity in data science. I think that that's a fine answer as well. But my question is more about within the field itself, not so much the tools, like not so much bias within the tools that data science creates as much as within the field. So I'll turn it to Lauren for that, but I think we might have a little more time. So if anyone wants to come back around, we can do that as well.
Sure, I'll just +1 to everything that Hima and Ahi have said. I think another thing that we might think about is the way that data science is taught. Thinking about ways that are in which these methods are presented in a broader context, so as to show what they can do sort of broadly and capaciously and not just in a narrow technical field. And, the other thing that I'll say, and it's related to that, is that I really think that we need to expand our definition of what counts as data science, right? We tend to prioritize, we now speaking like, from within, where I operate, sort of social and technical fields, we tend to prioritize things that make methodological innovations, that make technical innovations, and we tend to devalue projects that make contributions that are socio-technical, that involve new applications, or even really sort of elegantly simple applications of existing techniques to really tricky real-world problems. There's really an imbalance in terms of what we value and reward and promote, and I think a lot of people coming from life experiences where they recognize that there's sort of larger problems in the world than like something speedier or more accurate, or, making, some sort of, I don't know, even larger language model or something, are more interested in these real world applications. And so I think that we really need a way to open up our own minds. Like, I think it's on us to say, all of this counts, all of this is valuable, and there's a place for all of this type of work sort of at the table right now. And honestly, I would say it's not even an issue, a lot of this work is happening already, right? It's just that we are not allowing it into this sort of elite and narrow definition of what counts as data science work.
Yeah, and to just add to what Lauren said, I think there's definitely a certain dose of humility that we need as data scientists, machine learning practitioners, to understand that we cannot on our own solve bias, right? Like Lauren said, it's a social technical problem. And so if we only focus on the technical aspect of it without borrowing from the social sciences or the people who are experts in that actual field, we're really not going to move the needle as much. The data that we collect is a reflection of the society in which the data exists, right? And this society is inherently biased. There are a lot of systemic issues, and a lot of all these things get, propagated through the data all the way through our models. And our technical solutions won't only solve it. So in terms of representation, yes, there's also, making sure you have like, who are you working with, right? You are trying to solve bias. Have you ever spoken to someone from the social sciences who actually have spent years understanding how the society works? So making sure that we're not going in with like, our models are biased, let's just fix it. But having a deeper understanding of society, right, that has reflected these biases, and making sure we're pulling in the experts as well to inform us of even our own biases. And I think that's really how we can move it forward.
And one last point I just want to add to all the brilliant points brought up by Lauren and Ahi is that I think we have a bit of a kind of a siloed or an isolated way of thinking about different fields, right? So, for example, we always think of a work as, this work is should be a certain way to get published at a machine learning conference, or this work should be a certain way to get published in an HCI conference. So we almost, I think that the incentive process itself is such a way that it's hard to do work that is more interdisciplinary and make it kind of count, right, and get incentives for it. Because you always, no matter what you do, ultimately you have to market it in such a way that it appeals to one section squarely. And in that process, I think the works have a risk of losing their interdisciplinary beauty, because now after doing the work, even though you might have done it with an interdisciplinary team, you're now just kind of putting it into this pipeline of, oh, this is how it should look, or this is what we should emphasize on, to make sure that this gets published in a certain conference. So I think there is need for more conferences that are accepting of work that does not have to fit a particular template and can be more interdisciplinary. Of course, I think there is more and more of that happening recently, but I think we need way more. And just, I think there should be good incentive systems to reward interdisciplinary work that kind of sits between disciplines and might not squarely fit in one. I think there is somehow a lot of talk about, oh, we should do interdisciplinary work, but often you don't hear people talking about what are the incentives and how can we improve the incentives for doing interdisciplinary work. And I personally, I think that's where the biggest gap is, and like in terms of the reward system, and we need to like really like put some serious thought to it and make concrete steps, or take concrete steps to improve that.
Great. Thank you. I definitely feel that deep within my soul as somebody who does a lot of interdisciplinary work and often has trouble finding a place to a sort of home field that it fits squarely in. All right, so we have a few minutes left, about 5, and I wanted to get to some of the questions from the Q&A. So the first question we have here is, how do we ensure we are collecting and organizing data in a way that is socially responsible, especially given the different versions and definitions for appropriate fairness metrics that are out there? Does anyone want to take that?
Maybe I can start. No one else. Okay, great. So yeah, I think that's a very good question, but also an incredibly hard question. And I think, as Anjali Patil, who's asking the question, has already pointed out, that there are different versions and different definitions of fairness. I think, as you can see, that basically demonstrate that there are different views on what fair could be, right? So I think clearly one of the, again, there is no like easy answer, or I'm not going to be able to give a one sentence answer to you that will answer your question fully. But I think there are different ways, at least, to try and improve our chances of like streamlining these data collection processes. And one is to just ask questions, right? So basically, when we have the data, just kind of probe into the data. What does the distribution of the data look like? Does this seem realistic? How does this compare to, like, let's say you have a data set, right? So, check what is the percentage of like different races in it, or like different genders in it, and also different age groups in it. How does that compare to national data, right? So if that is where you want to deploy a particular model or apply the model that you're building. So I would say asking these very basic questions, I think you'd be surprised to see how many times people don't ask these kinds of very bare minimum questions and do some basic checks on distributions to say, is this really like the kind of distribution that we would have in our country? Or is this the distribution in the world, or a particular state that I want to deploy my models in? I think those bare
We're running short on time, so I think let's move to another question, if that's all right.
Yeah.
All right, great. So this is more of a comment than a question, which always happens in panels, but I think there's a question buried in this, which is how to train the next generation of men for the field itself, and to mix other viewpoints, experiences within the curriculum and student body. And I think that one's probably directed to Lauren, who talked about expanding the scope of what counts.
Sure. I mean, I think this is the question, right? I mean, so much of the time, the problem is presented as it's a pipeline problem. It's why aren't the women here? Why aren't there more people of color here? Like it's they're our problem, right? Instead of like, what's the problem with the men who are creating the environment where no one else wants to be there? And so I think, to the extent possible, trying to reframe the question and saying, look, the responsibility really does need to shift here. There is a problem in the environment, in the current environment, that needs to be solved, rather than placing the burden on the people who are not feeling welcomed or supported in that environment. And I think this actually leads to a follow-up point somewhat indirectly that I wanted to make to Hima's comment. I just wanted to alert everyone, if they're not familiar with it already, to the amazing paper Data Sheets for Data Sets. And it has Dr. Timnit Gebru as the first author in that paper, but it's also a Microsoft research paper, I believe, that has a really amazing list of comprehensive questions for exactly addressing that. The question of like, how do you know that your data is telling you what you think it is? But as we know, like with Dr. Gebru, she was just pushed out of Google ethical AI because she was a Black woman trying to operate in this predominantly white male space that just refused to make space for her, right? That was not her problem. That was the problem of the environment. And so I think it's really, especially for us, for me, for someone like I'm tenured, I am a white woman who enjoys an incredible amount of privilege in my field, amidst minor microaggressions, but like it's on me to continuously, and other people listening, to point out that it's not our problem, right? Like it's not the problem of the people not there. It's the problem of the people there to make the space for those perspectives.
All right. I think that is a fantastic place to stop, both because that was some great final words and also because our time is up. Exactly. So thank you all so much for your words of wisdom in this panel. I've really enjoyed talking to you all.